Hey, you're back. Hello, everyone. Welcome to the first online workshop and the first panel discussion. We want to give a huge shout out and thanks to the First Tech Challenge team, 12518, Allman Robotics, for developing and organizing this series. This is the FTC Coaches Panel, and this is new to us, and we're asking for your patience as we learn together how this works and work through any kinks that we may encounter. It would also be really helpful if you could, after this is completed, fill out the survey so that we can pass along the suggestions and make improvements for the panels that are following later on in this week. Speaking of, there are still some spots left in the Tuesday session at 7 p.m. and that one's going to be on FTC judging. And then there's the Friday 7 p.m. session, which is with a lot of head referees that are going to have a lot of good information for teams. All right, so due to the large number of participants, we are accepting written questions through Slido. So I know that you received directions on how to get on Slido and the link. So I hope that's worked for you. And please use that app to post questions and also to upvote any topics that you're particularly interested in. All right. So we're going to start off by doing a quick round of introductions. You can see on the screen there's all our pictures and kind of who we are. I'm going to do this in alphabetical order. So I'm going to start with myself. I'm Amber Dreisman. I've coached FLL for 4 years and then FTC for 9 years. I coached 4318, which had the various names of Green Machine, then Green Machine Reloaded, and then Stacko Cats. Currently, I am the founding director of a nonprofit called Tech Action Foundation, and we organize the Maryland Tech Invitational, which is an off-season FTC tournament. All right, Brad, could you tell us a bit about your background, please?
So I've been doing FTC for 4 years. My daughter wanted to start a team at Brunswick High School. It's the smallest high school in Frederick County. And I managed to avoid coaching soccer and basketball for many years. So when it came time for finding a mentor for a robotics team, that seemed to fit with my background as a mechanical engineer. So I jumped at that opportunity. My daughter's now in college and I'm still working with the team, and my day job's mechanical engineer, and I enjoy working with the kids and trying to introduce them to technologies that they'll see in the future in their STEM classes at college if they choose that.
Okay, great. And Dan from Mechanical Paradox. Are you on the line there, Dan? I see that you are, but it looks like you're muted. All right, well, we're going to move to, we'll circle back around to Dan. So
I got it.
Oh, you got it? Okay, cool.
I got it.
Let's go.
So the question was?
Oh, just introduce yourself.
Okay. I'm Dan Barvinick. I'm the lead coach of Mechanical Paradox, FTC 7182. I've been coaching for 7 years now, FTC. Like many coaches, I got into it because of my kids. We were looking for STEM activities, and after a year doing C-Perch, we wanted to expand, and we did start at FTC. And I've continued coaching not only for my kids, but for a large variety of kids on the team, and I've gotten a heck of a lot of enjoyment out of seeing the kids grow and learn through the process.
All right, wonderful. Dawei?
Hi, this is Dawei Lin. First, I want to thank everybody joining us, and especially the panelists today. It is a very difficult time. I know everybody have your life priorities, and then we come together in a very short period of time to think about inspiring kids and then care about their education. I think as a team, I think we really appreciate there's so many people with so many talents and expertise come together so quickly. Seeing that, I think so I have been coached for 7 years, and just I think based on the feedback that our kids say, like the school is boring, and then there's nothing that exciting to do. Actually, I think really thing is not really that school is boring. I think is teaching different skills, and is at school probably more teaching about the kind of critical thinking skills, but we really want them to learn some life skills. And so in that case, we need to put them into like the real life situation. However, we want them to feel in the safe environment. And then we found out the first program is ideal for that, and they have enough challenge. When they lose, they cry. When they win, they cry. And so it's sort of the right environment to simulate a real life. And we have been doing this for 7 years, and we love every moment of it. And so we're continuing to do it.
Excellent. And John Vandergriff.
Yeah, hi everybody. Yeah, I've been coaching for a while. I coached FLL and then FTC. This is my 5th year doing FTC. And same thing, got into it with my older son. My younger son's in it now too. And our team's gotten slowly bigger over the years. We have 10 kids on the team now. So it is, like a lot of the coaches have said, ends up being a diversity of things. But I really like it because it provides a long-term project that the kids can work on that's, you know, where they get to learn initiative. It's very hard to teach initiative, but by that second season, they really start to think way ahead and do lots of long-range planning and stuff. And that's hard to do in a school setting where it's, you know, the kids are in charge of something that lasts that long. That's part of what's interesting about it for me. So I do software development for my career. So I help coach the software team, and we have another coach who helps with, well, he helps with everything, but he's helps somewhat on the hardware side too, and electronics.
Great. I did want to mention also, none of us brought this up, but the audience may be interested in knowing that all of our teams have qualified for Worlds at one time or another. So we have had the opportunity to compete at several levels in the first program. Since many of you are making the move to FLL, from FLL to FTC, we thought that we would share this graphic that Almond Robotics put together about how the elements in FLL track to FTC. So Samuel, if you could put up that slide, that would be terrific.
Samuel, can you put the second slide on the FLL team?
There we go. So this is sort of putting it in the language of FLL, how that could be translated to where those skills would be in the First Tech Challenge. I don't know, Dawei, did you want to speak a little bit more to this, or is it?
Yeah, sure.
Sure.
First of all, I think that the FTC, I think we kind of just correct today is from 12-year-old to 18 years old. So the FLL is, I think is a stage that people just start learning the engineering concepts, and also the start work together with other kids, and then experience some independence that they can think about problem and solve a problem. So as a very starting age of the science and engineering. And when they move up to FTC, you can see that, like, from the core value that in FLL is to a much real experience, like working with the teams, and sometimes it's not just about their own teams, but the other teams. And not only that they will learn their skills, but also pass on the skills to younger kids. And during this process, they will learn how to compete with each other, but also help with each other. And that's the gracious professionalism is a very important concept in FIRST. And then the kids just kind of grow with the age grows. And then from project that they will from FLL, they just do like one project and have 5 minutes presentation. But in FTC, they have to really working on solving a problem, and the much complex the engineering problem that sometimes they really need to talk with professionals, and talk to professionals in FLL is important, but in FTC is crucial. They need their mentoring, and they need to know what is actually can be done. And also like the move to the robot is that, so FL is sort of like the starting. I know for some FL coaches, it's already daunting to get the Lego robot working, but in FTC it's totally different ballgame. I think the robot they build have potential for real life applications. So those skills they learn can solve real problems. But in competition setting, that they like FLL have a theme and they have a game, and everybody do the same thing so they can compete. But in FTC, not only that they need to build the robot, but also need to figure out the strategy, how to gain the most points, because you will have alliance and with the components, and those things are much complicated, and there's technical challenges and social challenges. So so in FTC there is much more things for kids to learn. So that's a nutshell. One of like other things we wanted to
right. I think the collaboration part of FTC is quite, obviously quite different from FLL, because you are working with a partner on the field, as opposed to FLL where you're on your own. I mean, yes, there's usually some kind of challenge in the middle of the field that you want to collaborate on, but it's very different when you're trying to strategize together who's going to do what part of the challenge. And then there's the whole, of course, selecting alliance partners and things like that. So it's more involved, but also a lot of fun. All right. So one of the things that that comes up a lot is, where do we start? What kind of equipment do we need? And what do some of the world-class teams use? And John Vandergrift kindly put together a slide about that. And we can also go around the panel and say what kind of equipment that we typically use during our season. So can we, Samuel, can we get that next slide up? And I'll just start saying that for our team, we use Actibotics. We supplement that with, well, of course we use the Rev modules, and then we supplement the Actibotics kits with additional parts from Servo City, from Andy Mark, and McMaster Carr are kind of the big ones that we use. But anyway, John, did you want to go over this?
Well, we don't need to read it, I guess, since
No,
people can see there. But that main point that you don't have to buy the kit that's recommended by the FIRST registration site. I think Dan pointed out that some teams, they buy that before they realize they don't have to, that there are other options. So if you're getting started, that's key. And then some teams, like Doe mentioned his team, they don't use too many kit parts at all anymore. They make a lot of their own stuff. So that takes a while to get to, maybe, before you can be comfortable doing that. But there's some standard pieces you do have to buy. The electronics modules, they're down to just sort of one key one right now, the Rev expansion hub, and then they're going to possibly update that this year with the what's it called, the core module, or
So
That's
you
right.
don't need a separate phone, I think.
right? Yeah, it'll
Yeah,
have
all be
the
one.
Android system built into it. You won't need a separate phone. So, and then these are the kits that have been out there for a while. The Go Builder one is the newest. A lot of teams really like that one because the motors will fit inside the beams, and so you can maybe get a little more compact for some things. A lot of these use different size nuts and bolts, and unfortunately my team has tried most of these, so we have pieces of lots of stuff. I don't recommend that. Try to stick with one or two. There are adapter pieces, but it just gets messy. And then Brad pointed out an important point too when we were preparing this, that some parts run out. You want the motors are certain, you can only buy certain motors. There's a restricted list. And so the really popular motors, the ones that really work well for the challenge in any given year, they are probably going to sell out. And so try to think ahead or plan early, or just be patient, and you might not get what you want. So other people can jump in on this too, other panelists.
So Dan, what kind of equipment do you guys use typically?
Yeah, our equipment has evolved over the years. We started off with Tetrix, then we switched to Acrobotics, and now we use GoBuilda. GoBuilda is made by the same company as Acrobotics, just so many people don't know that. But it is a newer version that they built based on lessons learned from Acrobotics and making it metric. We really like GoBuilda a lot. We use primarily GoBuilda. We supplement with an occasional Rev part and some things from Andy Mark, as Amber said, McMaster, Home Depot, Lowe's.
Right.
Also, another key one that's not on the list for linear slides is Masumi USA. That we use those for linear slides. But really, when you invest in a kit, you invest in a build system that if you're going to do it more than 1 year, which most people do, you're making a multi-year commitment in that sense. And so doing some research, looking at each kit, what they can do, and talking to other teams is really important, because rookie teams, the first thing they go to is the first website, and you typically pick from one of two kits, and right now it's Tetrix and Rev, and make their decision before they even talk to another team. And only then they realize, we've talked to teams just this past season at kickoff and talked to them about some of the other options, and they had already made the commitment and bought the kits, and it was too late by then.
Mm-hmm.
Right. Yeah.
So Amber, can I just add another point?
Sure.
I think as John said, that our team this season, they really rely on the CAD, the computer aided design, and the CNC manufacturing, because our Rockville Science Library, that they offer the CNC for us to use. But I think the point I was trying to make is that when our team make their customer parts, they still can drill the holes using the acrobatics and go build a pattern. And so if there's certain parts like from those, the kit are suit our need, and they can still mount it. So I think that offers the flexibility of customer design, but also can take advantage of what the existing solution is.
Right. And how about you, Brad? What's Minerva Mechanics?
Since we're one of the newer teams in this panel discussion, we've struggled with this whole process. We bought the Tetrix kit and immediately ran into a few problems. And somebody had a pile of 80/20 extrusion material that they were getting rid of that I inherited. So we'd already spent our budget, but we ended up building our robot chassis and out of 80/20 our rookie season. And neighbor is a machinist, so we designed some bearing blocks and we got a robot running, pretty much a from scratch robot our first year. And what we learned out of that is that you got to be very careful what you buy up front, as Dan has said. And we didn't even know what the word actibiotics was that first year. And so we learned about that the second year, and we've been investing in the actibiotics parts, and we've been buying Go Builda parts also now. And if given a choice, I would have skipped all those first 3 years and gone straight to Go Builda. We supplement things with a number of custom-made parts, but I can't stress the importance of trying to get the kids involved in 3D printing, because you can complicated parts.
Right.
They can learn the CAD, they can learn the 3D modeling, and the 3D printing is very forgivable, very economical, and it gets them to another level if they can integrate in that 3D printing of parts. And so that you don't necessarily have to rely upon a machinist or capabilities that you have access to for machining the custom parts. The 3D printing is a real game changer, I think.
I agree. Yeah, absolutely.
I think
Well, that kind of, sorry,
we-
Dan, go ahead.
yeah, I think all four of us probably use 3D printing on our robots, and
Yeah.
see everybody nodding. Yeah. So
Yeah, we do.
having a 3D printer or having access to a makerspace or something like that is very advantageous. It also teaches the kids about CAD skills, and as Brad said, the ability to design a custom part is just and then just print it and see it like the next day is just fantastic for the kids.
It really is. All right, well, that kind of brings up budget, and that is one of the questions that has popped to the top here. What is the minimum total budget for a team for the first year, and then for subsequent years? I would say for us, for a rookie team, I would recommend a budget around $3,500. Now, that's not going to get you a 3D printer probably, but if you have access to a makerspace, or you can, borrow someone else's. But I would say that 3D printing for a rookie team might be a bit of a stretch. There's a lot to learn. But it really depends. You may have some kids on there just, really excited about 3D printing and want to dive deep, and then, you support them if you can. So, and then after that, it really depends on how long your season is.
Right.
So, it can go up to 10,000 plus if you actually go to Worlds and you're trying to cover the travel expenses within the team budget rather than having parents foot the bill for that one. So, but that's my take on it. Other people have different levels that they work at. Dan, do you have something to add there?
Yeah, I would say it very much depends on your goal. And as a first-year team, if your goal is to just compete and get your feet wet, or how much you are able to contribute, I think 3,500 is a very comfortable number for a rookie team. You could go less, but it's tough. I don't think it's terribly realistic if you include. But it also depends on what you're lumping into that number, because there's probably at least 500 on competition fees.
Right. That would be the whole ball. Like all those fees for the registration and the
right.
And the
So I think that's a good starting point, and certainly the way we've done it is we've never been able to fund travel by other means other than maybe a small stipend for people.
Mm-hmm.
So mostly travel ends up being on parents' shoulders, but easily 4 to 5, 6, 7, 8, 9, 10.
It depends on the challenge.
It really depends. For us, sometimes we overbuy and we have surplus for next year,
Mm-hmm.
and depends on how accurate your planning is as well. If you plan very carefully, if the kids do computer-aided design and plan things out, you can be very smart in buying. But sometimes it's really advantageous for kids to just have parts on hand so they can look at them and feel them and pick them up and say, oh, wait, I can use this part with this over here. And just seeing them really just adds a lot, I think. So for us, we tend to try, one of the things I do as a mentor is I try to make sure they have a certain stock of parts on hand that they can just see and pick up, and in a meeting they can kind of brainstorm and have on hand.
Yeah, absolutely.
I think that's critical. You know, having gone from over 4 years now, from ground zero to where we are now, if you don't have the parts for the kids to see, they're not going to really progress in their design capability. And those parts for us, we're spending our first couple years about $4,000 to $5,000 just to try to build up an inventory of parts. And then the big thing is if you got more kids, you need more parts. So that's my theory, at least. All busy and working and trying to work in parallel, so your budget can float up a few more $1,000s in a given year. And then parts are consumable. You can break things, you can things out, and you can you're going to need to replace them. And so it adds quick. I would say, you know, $5,000 to $6,000 per year after your rookie year, after you start to really get into it, would be a reasonable number to you know, keep things going. But yeah, we spent like 10 grand on travel just to Worlds last year, so that was strictly travel for all the kids.
Right, and then there's the $2,000 registration fee, which is,
Well, that was part
a lot
of
fun.
yeah.
Yeah.
So
Okay. How about Dawi? Did you want to share thoughts
I
on that?
think the other panelists covered it pretty well.
Okay.
Yeah,
All
I
right.
think so.
You guys, okay, cool. So how about outreach? That is another question that people would like to ask. What kind of outreach do we do, and how do you find these outreach opportunities? John, did you want to talk about that?
Sure. Yeah, we've sort of fallen into a pattern with some outreach events, but we do a lot of things like STEM fairs or maker fairs. The Silver Spring Maker Fair is called something else now. I think they called it Future Fest last time. We're a 4-H club, so we do 4-H events. There's a parade at the fair every year, so we built a different robot and we drive it in the parade and let people know that, hey, 4-H is about STEM too. So there are school STEM fairs that you can go to. I learned about some of them prepping for this call as other people talked about things, robot festivals and so forth. So there's more and more of that kind of thing coming up. There's the USA Science Engineering Festival, which like a lot of things has been canceled this year, but you can try to get into big ticket things like that or join up with other teams. We try to do scrimmages with other teams, or we try to do you know, other meetups. We also got a grant to purchase some Sugo kits, and we've been doing that this year. That's really fun. That's it's a Lego kit, that the EV3 kits, or you can use old NXT ones. But the a Lego kit and then some extra parts that you order. It's actually another FTC coach, Phil Malone, invented this. So we order those and we got some on a grant, and then we hold robotics workshops. It's about a 4-hour thing, and it's FLLH kids. A lot of them have never built robots before. You just drop the kit on them and say, hey, build something, and then they have a competition at the end. Tons of fun. And we run those like on school break days. And so it's a combination outreach and fundraiser. You know, we're watching people's kids for 4 hours, so we charge like $30 or $35. And then, so that's a combination thing that we've done. So those are some of the things that we've done. I better let other folks chime in here too.
Sure. Anybody else?
Yeah, I think I want to add a little bit. I think for outreach also, it depends on the goals, just like you do for engineering. And I think for our team, I think early on, we said the goal is to inspire kids the lifelong passion for STEMs. And so to achieve that goal, we have 3 tiers of activities. The first tier is that the kids who are very busy, they they just try it out to see if the STEM is their activity. And so we offering classes or teach them, and then they try it out and they either stay or not. And if they want to stay, and then they probably can do something like longer, like FLL for a season. And then we kind of coach those kids, spend a lot of time with them if they want to. And then if the kids are dedicated to the robotics, and then they will join FTC team, and they will spend a lot more time on it. And so during this process, I think that we adopt the model like to focus on the impact of the kids. So some kids, like for example, stay with us for 3 years, and kind of teaching them and get some donations from parents to keep the activity going. So that's sort of like our model for outreach.
Well, I'll just jump in and say that we did Sugo as well. It's a great, I joined John and given a big thumbs up to Phil Malone and developing that.
Well, we learned it from you. You taught us Sugo how to do.
That's true. I did.
Yeah.
Yes, I remember, John. way back then.
Yeah.
One thing that we've done is something called Go Baby Go, and that is a program that was developed at the University of Delaware to adapt off-the-shelf ride-on toys for children with mobility issues. So you get these buttons, so that you disable the foot pedal, and you wire it so that it can be used by a big button that's on the steering wheel. And that's something that we've also made more tailor-made cars for specific children, but we've also brought together robotics teams to build these cars, and then given them away to places like Easter Seals. So it's a great program. I'm assuming we're going to be giving our contact information out, and if anybody wants to learn more about that, I'm happy to tell you about it and how you could get involved. And how about Dan and Brad? Did you have anything you wanted to add about outreach?
Yeah, I'd be happy to if you don't mind, Brad. One of the things that we do, one of the 3 areas, we do the demos as mentioned, but another key aspect is going to companies and getting tours. And this can lead to sponsorship also. So we will reach out to companies in the area, engineering companies, STEM companies, and ask if we can explain that we're a high school, mostly high school or high school, middle school robotics team. We're also a 4-H club, and that we are looking for companies that would be willing to have us come out and do a tour. And one of our new parents, a rookie parent on our team, she and her daughter did that this year. They called about 8 different companies, and about 2 of them ended up panning out. And it looks like we'll be going to one once this whole COVID thing is over. But the nice thing about doing a tour is you not only get the kids exposure to STEM in the real field, in the professional world, but sometimes, like I said, it leads to sponsorship, as engaged companies will say, hey, what can we do to help? It can lead to additional mentors. We've had multiple professional mentors where someone at the company will say, can we help? And we say, great, we'd love to give you some, show you our design as it's evolving, and the kids send them pictures or ask for advice. And then next thing you know, you've got a technical mentor, and sometimes even grants.
Excellent.
I'll just add real quick. Our team's associated with the public high school in Brunswick, and so we focus a lot of our local outreach with the elementary school in our area that feed into the middle school. We do outreach programs at the middle school, and then we also do outreach within the high school. We have also a local library, and we put on programs there. We put on programming classes there for the local kids, and we're targeting a younger age group to expose them to robotics and STEM. And it also serves to generate interest within the community, and it helps with our fundraising. And but equally important, it generates interest within the kids. So as they're coming up through the middle school and they come to the high school, we have kids that are eager to be on our robotics team.
Mhm.
Wonderful.
Can I add one more thing?
Sure, of course.
Another aspect of why some of the parts of your robot may be consumed is after your first year, it's sometimes nice to keep your robot together, because then you can use it as a demo robot for the next year. And that's really, really a great thing for outreach, to be able to go early in the season before you even start building anything. You have last year's robot and the kids can show it at a fair or at a whatever. So that's a really good reason to keep your robot together if it's, for demo.
Absolutely. We always tended to start taking it apart later on, but we would certainly try and keep it all together for the first September, October for demos. Because robots are just such an attraction for people. They're really like puppies and robots, right? All right. So engineering notebook. What do you do if no one wants to work on the engineering notebook? This is a very common problem, I think. So what do we think? Who would like to start on that one? Nobody?
I can start.
Please, Dawei, go ahead.
Yeah, I think the normally that you will find. I think it's probably like is lucky in our team. We have one person is very passionate about notebook, and she is also an artist, and so kind of working on the framework, and that lead. And also the kind of leadership exhibit from that, I think it gave people, a team, a sense that need to all contribute. I think one thing I noticed this season is that actually my son is a CAD lead, and he sometimes doesn't really write a lot. But since the CAD have a lot of good pictures, and he got the version out of that, from the CAD software to use, and every team member like say, "Wow, you did a great job," and those type of congratulations, and then help him, like he worked really hard, like past midnight to get all the CAD notebook done. I think one point I think I want to make out of this is sometimes it is a team culture that you emphasize. This is a really important thing to do.
Okay.
I think it's really important to emphasize to the kids that, and this is where coaches and mentors come in with getting some experience, that the engineering notebook is foundational to awards, and for kids that don't, they get into it for the robot a lot of times. They want to build a robot, but they also probably want to advance, because going to qualifications and not advancing is not fun, right? It's everybody wants to advance further. So helping them understand that at least 50% of advancement is through judged awards, and basically every one of those judged awards requires an engineering notebook. So if you want to advance, of course, do the robot, but that notebook is foundational.
Yeah, we have a kind of new generation of kids on the team, and it's taken them 2 years to really understand that. But they kind of get it now. They're sort of fired up about it for next season.
I'm in an odd position. So for the last 4 years, I've had more girls than boys on the team. So I've never had an issue of kids interested in wanting to do a good job on the engineering notebook, doing a thorough job. The struggle was always to find what is the best format, what should it really look like, and what information should we capture. But our kids would always work very hard on that. But I think it was the girls that was pushing that.
Mm. One thing that I started doing in the last few years was to have notebook meetings offline, like not during our regular, building and programming meetings. So we would do a Google chat and we'd have the notebook pulled up and it would be like, here you go. And, there was one of the students was involved in it, but I would be there because frankly, if I wasn't, then they may not show up to do the meeting, plus you just want to keep it professional. So that
I
helped.
want to add one more thing. I think
Mm-hmm.
so. This afternoon, the kids asked Heather and Aisha like, how thick your notebook is. So I'm kind of bring it here for the team haven't seen the notebook before. This is like one of their 2 notebooks, and
Yes.
it's a lot of work.
It is, and it's a beautiful one. I remember seeing it in a judging session. I suppose I'm not supposed to tell you that, but it's very nice.
Yeah, thanks. I think our kids will love to hear
But
it.
yeah. So, but anyway, so that was helpful because pulling them away from working on the robot to write in the notebook is particularly challenging. At least that's been my experience. So having a time during the week, even if it's just a half an hour, where you all get online together and they kind of work together and chat and fill out what they've been doing. But I certainly closer to your meeting, not farther away, because they'll forget. So that's
we've done we've split it sometimes when the years when we've had a larger team, like up to 9 people. We've had the kids take turns at the meeting and say, okay, well, you guys are going to work on the notebook right now while this robot work is being done, and then they'd swap out.
Mm-hmm. Yeah, that's a good idea.
And some of our smaller teams, like 4 to 5 people, we did a lot of it out of meeting. But I think it's important to emphasize that everyone, and this is something we do in recruiting members, is helping them understand everyone on the team shall write in the notebook. It's part of being on the team. Absolutely. It's important. And but it's not anybody's job, period, to write on the notebook. So everybody should be doing technical things on the robot and writing in the notebook and doing things for outreach, all of them. At least that's how we run our team, so that everybody's doing all of those things.
Mm-hmm. Okay. Is that what you guys generally do? Do you have everyone working in the notebook, or do you have one person who's sort of we would have one person sort of in charge of making sure everybody is writing in the notebook, but they would not be writing in the notebook, like doing only one writing in the notebook.
Yes, that's what we did. We tried to have the notebook coordinator person.
Mm-hmm, exactly.
And yeah, they have to really want to do that. Otherwise, it's not going to work if that kid doesn't actually care about it.
Exactly.
So we struggled to find somebody who did. We've never had anybody who just really went for it. So it's always been a struggle.
Okay. All right. Well, let's see. We are getting near the end of our session here, and we thought it would be helpful if we sort of just went around the panel and talked about, like, what lessons what would you wish you had known your first year or second year that you've learned now that you've been in the program for several years? What would you wish you had known back then? Would someone like to go first, or I'll go first? I'll go first then. Because it kind of goes with what we were just talking about in regards to judging. It took us, embarrassingly, probably a full year of competition to understand that initial interview is absolutely key to being considered for an award. We were under the impression, because even though the times when they didn't do all that well in the interview, we would sometimes get pit interviews. So judges would come and interview the team in the pit that, oh, we must be, we did all right then. And it turns out that, no, that's not it. Sometimes in events, they will do that just so that the kids get more exposure to the judges. But if they tank that first interview, they basically don't get on the board for any awards. And as Dan mentioned, progression is about 50% on awards here in FTC. Plus, it's nice to be recognized. Whether you would advance or not, it's certainly wonderful for the kids to be recognized for their work. And they can do wonderful, wonderful things, but if they are not impressing those judges with that first interview, there's just really no way to make up for that during the course of the day. So that is my advice, is practice, practice, practice that interview. Do not dismiss it and have them just wing it. They do need to make an impression. So that's my bit. Brad, would you like to share some best practices or things you wish you had known back at the beginning?
The importance of working in parallel. We tend to have 12 to 14 kids on the team. So it's a management problem of keeping everybody busy, but it means that we're able to work in parallel to get more done. And, but of course, keeping them all moving in the right direction constantly that's the challenge. But so the big thing that I try to do is keep last year's robot together for demos, but to try to get the kids to start doing autonomous programming as soon as the challenge is released, because our programmers are constantly changing on us. And so they need a period of time to ramp up their skills. So trying to work the autonomous programming in parallel as you build your robot with the build team is one strategy I employ to get to the end goal there.
Okay. Dawei?
Yeah, I think so. The things we learned is that I think I saw the question there, that the strategy for the season is very important. And at least in this several years we participate, that the game each year, the most exciting part actually get the least point. Like, for example, your stacking is the least point. And so then the kids sometimes, at least for first year that we're doing it, we kind of implemented the mechanisms, and then turned out we didn't get a lot of points. And so I think that that strategy analysis at the beginning of the season is very important. And this season, actually, we took, I think, 2 to 4 weeks, just analyze the game. We're not building anything. Mm-hmm. And then design in a CAD is slow at the beginning, but when we go through the season, I think in the end, our robot is really solid. I think that as probably some of you know, like, we kind of win the finalist, and our auto is very reliable because the robot is very solid. And then that add the software, make software is easier to make the robot solid. So all those things has coming from the initial strategy analysis, and we wish we would do that like 2 years ago, but I think now our team learned.
Mm-hmm. Mm-hmm. Good points. How about you, John?
Yeah, the one thing all the coaches mentioned was leave lots of time for driving practice. And that relates to another kind of lessons learned thing, is that the kids are going to envision lots of things, and they're not very good at making a realistic schedule. So having a season strategy that sort of builds in chances for them to learn that, so that if you go to an early tournament, they have a forced deadline, and then they'll start to realize, wait, this is a lot to get done. So having chances for them to learn that within one season is very helpful. Because then if you show up at a tournament where you've had one day or almost no days of driving practice, it's just not going to go very well. So it's easy to see that after you've been through it. And so that's definitely a lessons learned. Other things would just be, trying to keep the kids on task and trying to help them just see that long-term view. Just trying to keep pushing that as a mentor. And also learning the flow of the tournaments before we go. One of our very first tournaments, we actually ended up being one of the choosing teams. Like we got pulled up because one picked 2 and 3 picked 4 and so forth. And our kids showed up with no idea what to do and no list of teams. So that was kind of fun actually to watch that happen. So maybe don't say anything. But they figured it out. But yeah, trying to maybe go to a tournament before you're in one and watch the flow and see what to do there, or meet with another team and ask them about it.
Okay, I guess that's me. Couple of things come to mind in addition to what the other coaches said, because they all said great things. One is a structural thing, the importance of lock nuts, Loctite, and structural support, because sometimes kids think they kind of slap things together and think it'll stay together, but as robots drive around, things vibrate loose and shake and fall apart. And it's very disheartening for the kids to get out there and have something shake loose or fall off. So really emphasizing that lock nuts and Loctite are their friends, and they will be very happy that their robot doesn't vibrate loose. And really being very vigilant. I mean, we as a team are extremely vigilant about Loctite and lock nuts. Every single connection is managed that way, and as well as electrical connections, because electrical things will come unplugged as well. The other thing that comes to mind from a judging point of view is a lesson learned that took us a couple of years to learn, is to really understand the judging. It's very helpful to have parents or mentors volunteer as a judge, because it was very eye-opening for us after several years of competing to then have a parent volunteer as a judge and say, oh my God, we've been doing it all wrong. It's like, to really understand the importance of not just the interview in general, but what are judges looking for in the interview. Sometimes you just can't get that unless you actually try it. And then you're at the other side of the table and you say, now I understand what judges are looking for.
Yeah. And did you have anything else, Dan? I didn't want to cut you off.
I think, no, I think everybody kind of nailed the points I had on my list. So
okay. Good. And I did just want to make one small note about the lock nuts, right? Loctite and lock nuts. Absolutely before you go to a tournament, but don't put them on at the very beginning until your design is actually, kind of finalized, because when you want to remove and move things around, when it's all Loctited and lock nuts, not such a fun thing. It takes a much, much longer time. So you definitely want to do that, but I wouldn't start out that way, just because they will move, they will want to redesign some things.
Lock nuts are a little more forgiving. Loctite is not as forgiving.
Exactly. And I wanted to mention about what we do for qualifiers is we always sign up for 3 because anything can happen. I mean, we've had qualifiers go well, we've had qualifiers go not so well. And if you're trying to get to the next level, giving yourself 3 chances is a good thing, if at all possible. And it's, as John was mentioning, it's really good to go early, because that kind of forces some focus on the team. But we would also be very strategic about what part of the challenge we would have completed by that early qualifier and leave room on the robot to add additional functionality as we move through the season. If you are going to a qualifier early and you can do 50% of the field 100% of the time, you're going to have a pretty good day.
Right.
But if you are going to there with a robot that your kids tried to build, you know, and it be all done by December, and especially if you're new and you're trying to do 100% of the field, and you're going to find it's going to maybe work 50% or 25% of the time. It's just, it's the nature of the beast. It's, you know, this is a process and it takes time, and kids get real excited about it and they want to go do it all at once. But, you know, if you can kind of hold them back a little bit and get them focused on making things robust, they will have a better time of it. All right, well, I think that's about it. Did anyone want to add anything up from the panel before we
I
wrap
think
up?
maybe we can, I don't know, have one more, we can answer one more question. I think that.
You want to? Okay, then
is-
student leadership, how do you organize the student leadership on the team is the question.
Yeah, maybe I can give a quick
Sure.
comment on that. I think the, in order for students to lead, I think coach has to go back.
Mm-hmm.
And I think that's sort of the things that our team is doing. And I'm the coach, but I'm not the one know everything. And I think the one important thing is that the coaches are now offer solutions. I think the most important thing is to ask good questions.
Right.
And,
Right,
and so that
absolutely.
sort of put the students into the driving seat, and then they will figure out what they want to do. And that's how like our team come to that leadership role.
Mm-hmm.
I agree. I think that's always the vision of a coach and mentor, is to get the kids to the point where they're fully autonomous. Sometimes they need a little bit of help, like getting started in something. So from a technical mentor, for example, using CAD the first time, you might need a little bit of help guiding them through something. But really, it's always the case of you're not doing it for them. You're asking probing questions, or telling them, have you considered something? And that's really, ultimately with the goal that they're fully autonomous and you're just there to kind of help in the background.
Mm-hmm. All right. Well, I want to ask again, just if we could make sure everybody does that survey so we can make improvements as we move through the week. Dawei, are we going to be able to, you're going to follow up with the survey, and then are we going to be able to share our contact information in case, because we didn't get to all these questions, and if people wanted to contact us. I don't mind, or go ahead.
Sure. I think so. I saw there were 17 questions out there.
Yes.
Probably not going to do this like today. And I think so what we're going to do is that we're going to put those questions in the Google Doc, and I probably invite the coaches to comment later, and then we'll release that link to the Google Doc.
Great idea.
We'll get your question answered.
Excellent.
Yeah, sounds good.
And then one comment I want to add is that I think we invite the coaches that have a lot of experience, but by no means I think I speaking of our team, like we're the best coaches in the community. I think we just like share some experience, and I hope that this activity will probably jumpstart the collaborations and the discussion among the coaches, like what is the best way to educate our kids. So I think we will really appreciate that when we send you the evaluation form, and please offer the ideas that what we can do. And one more thing I want to mention is that so this week has been very inspiring week, and we have a lot of enthusiasm of the online workshop that the teams put together. And now I think probably next week we're going to need some more content. And so we have an instructor sign up sheet. We'll send in an email, and please add what you can offer, and then we can organize in terms of technology, using technologies.
Oh, that's wonderful. All right. Well, thank you everyone for participating. Thanks to the panel, Brad, Dawei, John, Dan, it's been wonderful. And thank you for all our participants. And I'm looking forward to the rest of the week. So with this series, excellent idea, Almond Robotics. Thank you again.
Thank you, Amber.
Thank you.
Thank you,
Take care.
everybody.
Yep.
Thank you, Amber, for moderating.
Yeah,
Sure.
stay
Yeah,
healthy.
thanks, Amber.
Yeah, everybody stay healthy. Yes, please. All right. Bye-bye.
Bye.
Bye.